Number 1, numero uno on worksheet 16. Number 1 is about cards. If 2 cards are selected from a standard deck of cards and the first card is not placed back in the deck before the second card is drawn, find the following probabilities after stating if the events are independent or dependent. So number 1, if you don't put the card back, does the second card depend on the first card drawn? Yes, so it's a dependent. You're not replacing it. It's without replacement, so it's definitely dependent, okay? So A, what's the probability of a red card and a queen of spades? Well, how many red cards are there in the deck? 26 out of 52, which I reduced that to 1/2, times, okay, so you're holding a red card in your hand, right? So what's the probability of a queen of spades? 1 out of 51. Yep. So then that probability is equal to 0.0098. Pretty low probability. Yep. Part B, probability of a heart and an ace of clubs. So how many heart cards are there in the stack? 13 out of 52, which I reduced that to 1/4 because a quarter of the deck is hearts, right? We have hearts and diamonds, those are red. Clubs and spades, those are black. Okay. So heart would be 1/4 times the ace of clubs. Ace of clubs. 1 out of 51. There's only one ace of clubs, right? You wrote that down. You just said it wrong. 0.0049. So you got? I quit writing this. Sorry. Because I was just using my reduced one. Okay, and C. What's the probability of getting 2 jacks? Well, how many jacks are there? 4 out of 52, right? So if you draw a jack on the first time, how many are left? 3 out of 51. And what is that? I actually didn't convert that. 4 out of 52 times 3 out of 51. 0.0045. 0.0045. Questions, comments, concerns? No? All right, number 2. If 2 cards are selected from a standard deck of cards and the first card is placed back in the deck before the second card is drawn, find the following probabilities after stating if the events are independent or dependent. So you draw a card, then you put it back in the deck and draw a second card. Independent or dependent? Independent. Because this is with replacement, right? So A, the probability of a black card and a queen of diamonds. So half the deck are spades and clubs, right? So 1/2 times, and then the queen of diamonds? 1 out of 52, because you put the card back. Yep. And what do you get? 0.01. Do y'all agree with her? That's fine. I didn't tell you what to round to, so that's fine. You agree? Awesome. A spade and an ace of spades. 13 out of 52 times 1 out of 52. Very good. Now that problem would be harder to do if it was without replacement, right? Okay, so what do you get for that one? Say again. 0.005. You second that? Thank you. Yes. Without replacement, you would have 13 out of 52 times. But the problem is if you draw the ace of spades the first time, like the spades, then you don't have it the second time. But if you don't draw it the first time, so I'm not actually sure. You know what I'm saying? Because I think there's 2 possible answers. It could be 0, because if you draw the ace of spades the first time, then you're not going to draw it that second. You know what I mean? But if you flip it and say, what's the probability of finding an ace of spades and a spade? Well, if you draw the ace of spades the first time, that would be 1 out of 52 times. So if you're holding the ace of spades, then you would have 12 out of 51. So I guess that would be the answer. Because you can flip the and, right? No. Because it's given, yeah. So if it's given that the first one was the ace of spades, then it would be 0. Yeah, so I guess it's not 2 possible answers, it would just be 0. Because the multiplication rule for dependent events is the probability of A times the probability of B given A. So if you draw this ace of spades the first time, then it's not going to be there the second time. So, but this is the probability of a spade. This is the probability of ace of spades, given that the first card was a spade. Yeah. That's a tricky, tricky problem. Okay, C. 2 kings. So that would be 4 out of 52, right? Yep. Times 4 out of 52, because you put it back. Do what? 1 over 13, yeah, you can reduce. So what do you get for that one? 0.00 or 0.06, I'm sorry. 2 zeros, thank you. 0.006, you second it. Thank you. Everybody good? Yep. All right, number 3, you said you didn't really love this one. You got A and B, right? Are the events the selected player's injury was ankle, foot, and knee mutually exclusive? Yes. Right, because just because you hurt your ankle and your foot doesn't necessarily mean you hurt your knee, right? Part B says, are the events female and face, scalp mutually exclusive? No. Because some of the females hurt their face and scalp, right? So they're not mutually exclusive. All right, then C, find the probability that someone hurt their ankle / foot. Wow, I can't spell. Ankle / foot, given, that's what that symbol means, right? Given that they're male. Okay? So if I look, go to ankle and foot, and how many of them are male, given that they're male? 38.3% out of 100%, right? So that's just literally 0.383. It's that simple. Because it's out of 100%, if it wasn't, you'd have to use that total for the row of males, but because it's out of 100%. Well, if you do it the way I taught you, right, which is first, I'm not saying, I didn't mean that to sound like do it the way I taught you. I mean, like, if you had done it the way I taught you, it means go to ankle, foot, and you have 38.3 and 36, right? But then it says given that they're male, so that's 38.3% though. Given that they're male, so then you use the male column. So divided by 100%, so that literally just changes it to a decimal. That's all it's doing. All right, D. D says find the probability not leg related given that they're male. So not leg related. Does foot count for your leg? Is your foot on your leg?
Yeah.
I'm not making. From your hip down is your leg. Okay, so ankle, foot, that's leg. Hip, thigh, leg. Knee, right? Forearm, wrist, hand, face, scalp, other. Bottom 3. So you add those, 11.2 plus 8.8 plus 14.4. And what do you get?
It's actually 11.5, 12.2.
Oh, I'm sorry. I was reading the female column. I apologize. Yeah, 11.5, 12.2, and 13. What do you get? 36.7. But then given that they're male, that's 100%. So 0.367. Okay. And then the last one, yes, I have a typo. Get over it. The probability that it's face or scalp, not scale. It didn't catch my mistakes. Knee or face / scalp, given that they are male. Or means you have to add. So, and given that they're male. So, knee, given that they're male, would be 10.3 out of 100%. So that just changes it to 1.103, right? And then plus 12.2, but that's divided by 100 because it's given that it's male, so 0.122. Add because it's or, so then it's just 0.225. We already divided. Knee, given that they're male, or face scalp, given that they're male. There's two ways to look at it. You can add knee and face and scalp, right, because it's or. So it's 10.3 plus 12.2, and then divide it by 100 because it's given that they're male. Or you can do knee given that they're male plus face scalp given that they're male. You get the same answer. Questions? Right, it changes it. Number 4, what is the probability of drawing 1, 2, or 3 from 9 cards numbered 1 to 9, replacing the card and then drawing a 7, 8, or 9? Are these events independent or dependent? You're replacing the card, so they are independent. Yeah, it doesn't depend on what you draw the first time because you put the card back. All right, so what's the probability of drawing a 1, 2, or 3 from 9 cards numbered 1 to 9? 3 out of 9. Which reduces to 1/3. And drawing a card. And means multiply. So, and drawing a card 7, 8, or 9. Yeah, 1/3 still. So that would be 1 out of 9 or 0.11. You good? You second it. I love it. All right. Use the image to the right to answer each of the following. So you were given 2 spinners, right? One spinner has 4 parts. It says A, B, C, and D. The other spinner has 6 parts with random 1, 2s, and 3s on it, right? Okay. So I actually colored my 1, 2, and 3 spinner to try to help me, make sure I'm looking at the correct ones. So the 1s I colored one color, and the 2s a different color, and the 3s. All right. So number 5 says find the probability of rolling a B and a 3. And means multiply. Yep. So rolling a B would be, not rolling, spinning, excuse me, 1 out of 4. And then times 1 out of 6. Because there's only 1 3 on that second spinner. So that probability is 1 over 24, which is about 0.042. Okay. Number 6. What's the probability of spinning a D and a 1? Well, how many D's are there? 1. So 1/4 times. And how many 1s are there? 3. 1/6. Or times 1/2. So 1/4 times 1/2 is 1/8, which is about, actually, yeah, that works out perfectly. 0.125. You second it. Perfect. Number 7, the probability of rolling or spinning, an A and not 2. So that would be the complement of spinning a 2, right? So probability of A is 1/4. Probability of not a 2 is 4 out of 6. 1/4 times 2/3. And then that would be 2/12 or 1/6. 0.17. Oh yeah, you can cancel the 4. Nice. Very true. Because I saw that I could reduce the 2 and the 4. But yeah, I like that. Does that hurt having a brain? I wouldn't know what that feels like. Seriously, at moments I feel that way. Very good. Okay, you have a bag that contains 6 blue marbles, 3 red marbles, and 1 white. The marbles are selected at random, one at a time, without replacement. Find each of the following. So 8, 9, and 10, I know I didn't write it on the directions to do this, but 8, 9, and 10, independent or dependent? Dependent. You're keeping the marble, so the second marble is going to depend on what you draw the first time, right? So what's the probability? Number 8 says, what's the probability that you choose a blue marble and a blue marble? So it'd be 6 out of 10 times. Okay, so if you're holding a blue marble and you don't put it back, you only have how many chances of getting another? 5 out of 9. See how that works? And then, yes, you can reduce, and if I'm going to be smart like him, I can make that a 1 and that a 2, and then 6 over 2 is just 3 times 1/9, or 1/3. So 0.33. Okay, number 9. 9 says, what's the probability of getting a white, a red, and a white? So apparently this time you're drawing it 3 times, right? So the first time, the probability of getting a white is 1 out of 10 times the probability of getting a red, 3 out of 9, because you're holding that first marble, you don't put it back. So then 0 out of 8. There was only one white marble, so if we draw it the first time, no way to get it again, right? A second white marble, so the probability is 0. Some of y'all can do that without showing that math. I get that. That's fine. That's just using deductive reasoning, you know, logic. Red, white, and blue. So the first probability is 3 out of 10. You have 3 red out of the 10 marbles in the bag. Then you draw the 1 out of 9, and then nail blue, 6 out of 8. I did a bunch of reducing, but let's just skip to what it is. 1 out of 40. So the probability of getting 1 red, 1 white, and 1 blue is only 1 out of 40, which only happens 0.025. Very small probability of that happening. All right, and the last 3 go with that table that has the rows and columns that have D's, S's, J's, and L's in it, right? So you have a collection of tiles as shown below. Suppose that you randomly select 2 tiles with replacement. Find each of the following. With replacement, so are these events independent or dependent? Independent. So I do want you to think that through because it does impact, you know, your probability. Same thing with mutually exclusive. It's like what we were talking about the ace of spades thing a while ago. All right, so number 11. How many D's if you replace it back? 2 out of 15 times 2 out of 15. So you get 0.178. Approximately. It means it's not perfect. Approximately. Okay, 12. The probability of S and L. 6 out of 15 times 3 out of 15. Good. And you get, nice, 0.08. And then the last one, 13, says the probability of a D and not S. So that would be the complement of S, right? So D is 2 out of 15, and then times, because it says and, so not S. How many are not S? 9 out of 15. So you get 0.08 again. Questions? You're good? Okay, I'm going to give you your test review. Okay? Because you're going to have your Chapter 4 test the next time you're in my class. Okay? That's not Friday. It's supposed to be Monday before the break. I'm giving you your test. And look at that. No homework over the break. Won't that be amazing?